Good morning, George Hepworth, Grover Park Consulting. Welcome back. In this episode, documenting our progress in migrating the Northwind Developers Edition template to PowerApps, we're taking a step deeper into the architecture of this project, focusing on how PowerApps handles data, how it compares to what Access developers are used to, and why I'm taking a different approach with unbound objects and named formulas. PowerApps gives you access to hundreds of data sources through what it calls connectors. This includes familiar ones like SQL Server, SharePoint, Excel, but it also includes things Access developers may not be used to, like Microsoft Teams, CRMs, or even public APIs. Access can reach many of these same sources too, but PowerApps streamlines that process through connectors. For example, in one project, I connected to the Google Books public API to build a library catalog for a nonprofit organization. I used the same Google Books API in VBA and Access. Although both were effective in retrieving the data, wiring up the predefined connector in PowerApps required significantly less work and less code. All that's available with connectors, and as of the date of this recording, there are more than 300 PowerApps connectors available. Now let's talk about data binding, something Access developers know well. I'll explain this briefly for those PowerApps and non-Access developers who happen to be watching the video. In Access, bound forms are standard. They're linked directly to a table or to a query and automatically handle edits, inserts, and deletes. In this form, there is a subform for the order line details. It is bound to an updatable query. Whenever a change is made through this subform, that can be adding a new record, updating one of the fields, one of the controls bound to one of the fields in this record, Access automatically saves those changes back to the table with no intervention. You'll notice that there is no add or delete button on the subform. Not all Access forms are updatable. Sometimes we bind them to read-only queries or use unbound forms for special logic or complex workflows, but most of our data entry is handled through bound forms like this. PowerApps also has forms, an edit form and a display form. Actually, it's a single form which can be displayed in either edit or display mode. These forms mimic this behavior, but they come with baggage. Every form requires the use of data cards, which are rigid layout containers, which in turn contain controls for input and labels. Think of them like Access form layouts that lock control placement. Here is one example from my library catalog database. You can see the two data cards, and here is the edit view showing the property sheet to the right. For some projects, these built-in forms are fine, but they do not offer the flexibility I needed for Northwind Developer Edition. In a previous video, I showed you the look and feel of the screens we need. Forms would not support that, so I went unbound. That means no use of PowerApps forms for edits and no patch calls. PowerApps developers will recognize the term patches. I don't explain patches in this series of videos. I'll drop some links to other videos that do document the patch command in other PowerApps apps for Access developers who want to know about that. They are very powerful and very commonly used in PowerApps. In this application, in Northwind, I collect data using controls, store values in variables, and then pass those values to stored procedures in SQL Server. SQL Server passes back either a response alone or a response together with a record set. Choosing unbound controls introduces a shift in thinking. You can't update data directly in flexible objects like galleries, combo boxes, or labels. So there's no strong reason to bind your UI directly to SQL Server tables. Instead, you can use intermediary objects like collections or named formulas to shape the data for display or for interaction, like using saved queries in Access for reports or for subforms. Let's look at the building blocks PowerApps gives us to do this. I've compiled a little table showing the 4 most important objects that I want to talk about here. Of course, we start with the database tables. In Access, they can be internal or linked. In PowerApps, they can be connected. So connection and linking are roughly equivalent concepts. Access has the ACE database engine, which means it's internal, and you can use that, or you can link to external data sources. Table objects. Access has no real strong corollary to table objects the way they're used here. PowerApps, they are an internal object, and the best way to think about it, in my opinion, is to think of PowerApps tables as being similar to Excel tables. Maybe like queries in Access displayed in datasheet view. Collections are the workhorses for most PowerApps applications. In Access, we have VBA collections, and they're vaguely similar. Be careful not to draw a direct comparison. In PowerApps, a collection is an in-memory table. I think of them as temporary in-memory table objects. They can be shaped, rebuilt, and deleted in memory as you use them. For example, a collection can be the data source for a gallery, which displays a list of items. Now we get to named formulas, and these are the most interesting from my perspective. Named formulas don't exist in Access. They're vaguely similar to variables in some aspects, and they're vaguely similar to DAO record sets in VBA, but again, I would not try to draw any direct comparison. In PowerApps, named formulas are global scoped variables. The formulas that generate these variables can calculate values. Here's where it gets interesting. Named formulas can contain single calculated values, or they can be whole records or sets of records, vaguely similar to the way properties are available to a VBA class. Once you have defined a named formula, all of the elements in that formula are available as enumerated properties of it. Let me show you some examples. Here are 3 examples of named formulas in PowerApps. The first one is the user email. That's the variable. It's defined as the email property of the user. Now, the user is the logged in user. Their email is available as a property of the user, and we assign that to the variable email. User email, I should say. User info. We can set this variable, user info, to an object. We look in the users table. We find the primary email, and we use the current user email value to select one user from the whole group of users. That becomes an object with multiple properties. Obviously, email is one of those properties. Once we have user info as an object, we can then take any of the properties defined for that object. In this case, I'm looking at title, and assign a named formula, which is the variable user title, to that property of the user info object. Title is one of the properties of the previously defined user info object. In addition to what you see here, these can be entire records from a table, or they can be an entire record set, filtered, sorted, and shaped from a table. Even better, you can assign the results that come back from a stored procedure to a named formula. That means the named formula can hold a full record set or a single record, shaped and filtered by the SQL Server database. Does that sound to you like one of the reasons Access developers sometimes use SQL Server? Complex logic handled more efficiently by the more powerful database engine in SQL Server? That's the core of my approach in this PowerApps version of Northwind. Number one, there are no direct SQL connections required because named formulas are so powerful. I don't connect my app directly to any SQL Server tables. Instead, I define stored procedures in SQL Server to return exactly the data I need, filtered, sorted, or joined as required, and load that result into a named formula. This gives me a tremendous amount of control. It eliminates the need for collections in most scenarios, and for better or worse, avoids PowerApps' default data binding behaviors entirely. Let's just take a look at a couple of these examples while we're here. The welcome screen. In SQL Server, I have a stored procedure called select welcome, and all it does is run a select query against the welcome table and return the records back as a table. It comes back as a result set in one or more tables. All of these will bring back a single result set, a single table. But if your stored procedure generates multiple result sets, they can all come back as table 1, table 2, etc. When it comes back, I assign it to a named formula called F welcome. I use the prefix F in PowerApps to designate named formulas. I've seen other conventions like NF. I prefer the simpler F. Companies. This one is more complex, but it operates the same way. In SQL Server, there's a stored procedure called CRUD company. The arguments passed to it are, what type of CRUD activity am I going to use? Will it be a create, a read, an update, or a delete? For the purposes of generating this named formula, I'm telling it I want to read or select the records. If I pass it the value of a company ID as 0, that will bring back all existing company records. If I pass it a non-zero value through this parameter, it will bring back only that single record for that company. Company type ID is also required. I also set that to 0. And when I get into the workings in the stored procedure in the SQL Server side, I'll explain to you more detail why I have to pass 2 arguments to get a single record. It has to do with the all or nothing nature of that request. Again, it comes back through the result sets in that stored procedure as table 1. Each of the other record sets that I need throughout the entire application are generated on start when the application starts up and stored in memory. These are dynamic. They will update. They can be changed. They're formulas. They're not static objects. However, I have found that in action, I do sometimes need to recreate the named formula to get the most current records. And again, that's something we'll look at later. So to summarize, PowerApps offers a wide range of data connectors, but binding strategy matters just as much. Access developers will recognize the strength of bound forms, but in PowerApps, going unbound using named forms and stored procedures can offer much more control and scalability. This app avoids patch. It avoids bound forms and avoids direct SQL table connections entirely. That means the front end is lightweight and responsive. Next time, I'll dive deeper into how I structure the stored procedures, how I handle the parameter passing, result interpretation, and even error handling within PowerApps. Thanks for watching. Make sure you like, subscribe, and leave a comment if you want to closer look at any part of this build.